Hello, everyone. This is Jim White from Jekson Vision. Um, this webinar is about the next generation tablet inspection system. Glad you guys could join us today. So let's get started. So again, my name is Jim White. I have 30 plus years of experience in pharmaceutical packaging and equipment design. It's great to be here today with you guys and talk a lot about vision and what Jekson can offer you for vision inspection. And I'll also talk to you about basic things of vision. Like for instance, we're going to talk about what to do with next tablet inspections, what product mix-ups can highly affect your company, what's the important part about tablet inspection and its applications, and how Jekson can help you in these applications. Jekson is a company that's been around for over 25 years. It does a lot of different things in serialization and vision and material handling. So we play in a lot of different sandboxes. Today, we're really going to focus in on the vision aspects of it and the different applications that Jekson can help you with. So the first question you have to ask yourself, why do you need a tablet inspection system? So these are be some questions and answers at the end of the day. Hopefully you guys will react with some questions about, why do you need a tablet inspection system? So do you know that recalls can lead up to $1 million in losses? This can be affected by a lot of different things. It could be a simple recall. Recall can cost you a tremendous amount of money when it gets outside of a facility. But if you've ever thought about reworking or an investigation based on reworking, it can cost you hundreds of thousands of dollars without the product even leaving your door, right? And if you have if you have an internal recall, that means quarantining the product. It means investigations, internal investigations. It means the line is shut down. So that's just mitigating it internally. But if you look at recalls when it goes outside a facility, that involves a tremendous amount more. It basically it involves the FDA getting involved, and it creates bigger challenges for your facility. It also it can affect a lot of different things, and we'll talk about that here in a minute. But it also a simple broken tablet, a broken tablet on a packaging line, either in a blister or maybe a certain type of bottle application. For inspecting, can stop a line, shut it down, and create an investigation. All these types of delays or stops in your process can really cost you a tremendous amount of money. So I've got 6 things here just to talk about in general, but obviously there's a lot more that we could talk about, but I have a limited amount of time here. One of the big ill effects, from a rogue tablet or something that's entering into your good product stream that's not supposed to be there. So for instance, if you're running like an OTC on a class 2 narcotic product and one packaging line at 2 different times, if you have a cross contamination, it could actually have a tremendous fatal ill effect on a person. So vision systems and our software is all about quality. You can have FDA audits and investigations, which can cost you a tremendous amount of money. You also could have an internal company investigation. Your whole facility could be shut down because of this. And one of the other big things is recalls can really tarnish, a company's reputation. It's really hard to put a number when you're talking about recalls and tarnishes on a company's reputation, because you don't really find out what those numbers are until years later, until the accountants and people see the ill effect of what that one thing did, that one recall caused a tarnish in your reputation from lost revenue. Maybe they had to change the brand to a different name. They had to just completely pull it off the market, doing an investigation. It's a tremendous amount of money that happens when you have a recall that's external of your company. And the question is, who absorbs these costs? Of course, the company who has the recall has to absorb these costs. So the next one we're going to talk about is this product mix-up, and really what does this mean? It can mean a couple of different things. I mean, these are true stories, life stories that I've experienced in my past 30 years experience as a mechanical engineer, um, as a global director for Jekson Vision, but I've worked with other different types of companies through my career path, my professional path since university. One experience I've had is I've seen firsthand where QA is taking samples. So you have a batch of product, and this batch of product has the same product family, it's the same color, it's the same shape, but the only difference between it is like a little over a millimeter difference in product. And QA, doing their testing, pulled bulk out, pulled product out, went to their labs, did some testing, brought it back in, and realized they put it in the wrong batch. They put it in the wrong product. So now you have a product mix-up. And what do you do with a product mix-up like that? Um, so they had a tremendous amount of money, hundreds of thousands of dollars, invested in like 12 to 15 pallets of product, and they have this product mix-up. So I've seen that firsthand on how that can happen, and we'll talk a little bit about the solution for that. I've also seen line clearance issues where a customer was running on one particular bottle line, and they ran a batch, did a line clearance, and 2 hours later, 3 hours later, after the line clearance had been done, everything had been cleaned up, they changed over and switched products. They started running. In the middle of their run, they realized, where did this tablet come from? And it was sitting right there by the filler. At that point, they just shut the whole line down. They brought, people from quality out. They shut the line down. They went all the way back to where this could have happened. So they had to pull the product off the line, and it took weeks to figure out, how did this happen and what can we do to prevent this in the future? So if you think about that, that's a tremendous amount of money. Whereas if they had possibly had a vision system on it, that could have, prevented for something, not so much the rogue tablet part of it, but it might have helped the investigation. Said, look, we have a vision system. It's got the recipe is set up on it. And there's no way that could have happened and gotten their bottles, and maybe it would have shortened that process. Also, defects found in-house. I've come across customers who have sent us products for vision and for vision studies and wanting to buy our vision systems, and they have found out by us just doing a simple inspection in-house with their products for testing, we discovered there was a discoloration on their coating process that they weren't even aware of, because our vision system, or a vision system in general, will be able to see the contrast in the different types of product color. Also, if you're a CMO and you're bringing products in from other places, either domestically or internationally, sometimes you have quality issues of products coming into your facility that's kind of really is out of your control, but you're responsible for packaging it. So when you get products in from other companies, you might find yourself in a situation where you've tooled everything up, you're running the system, and you're starting to have all these rejects. All these things are happening because of broken tablets, and you have to shut it down. And then again, you have to investigate. You have to pull the product back. So it takes a lot of time. It takes a lot of money to mitigate that process. So why is it important to have a tablet inspection? I mean, in a lot of cases, it's pretty obvious, but let's just go through the 4 points here. It ensures quality of the goods being provided to the consumer. That's huge, right? Because all of us as consumers want to make sure we have the right product in the right bottle. It saves millions of dollars from recalls and a lot of internal and external investigations. Credibility and negative impact on your brand reputation. Sometimes companies are big enough to absorb this type of negativity and cost effectiveness. But when you're a smaller company and you're just getting your feet on the ground, something like this could basically shut the door for you. Um, increase of overall efficiencies. This is a really big thing about, and we'll talk a little bit about that later on in the presentation, about how a vision system can actually increase your line efficiency and line throughput. So the other thing I want to talk about is with a vision system, you have things, for instance, if you're running, let's say a TIS system on an electronic counter, it could be any types of electronic counter. You could be filling, but if you don't have some type of vision system on there, your tablet counting system might be trying to be set up as a tablet counter slash broken tablet reject system. A lot of times that's really hard to do because your counting technology in a lot of cases is sometimes 30 plus years old in the counting technology. The sender and receiver, it's seeing dark time versus light. And so you're measuring the amount of scan time it's actually passing through that beam of light. And a lot of times that's in milliseconds. Sometimes even in microseconds. But as the tablet is falling down, you're measuring the amount of time. And sometimes they can see broken, but a lot of times they can't. But they try to do it the best they can. When you have a broken tablet being detected and rejected in your bottle, that filler normally has to stop, open the gate, reject happens, and now a person has to go and take that commodity of bottles, and let's say it's a 90 count, they have to dump it out, figure out where the broken tablet is, and then put it back in the product hopper. In some cases, you can't even do that depending on your SOPs. And then they have a commodity, which is a bottle they have to throw away. So now you're talking about commodity loss, you're talking about production loss, because every reject could possibly take you up to 15 to 20 seconds just to reject a bottle. Now you do that 100 or 200 times in a batch run, that can cost you a tremendous amount of downtime. And we'll talk a little bit about how the TIS can help you with increase your overall line efficiency and your throughput. So the four different applications that Jekson's very proud of. We are really involved in electronic counters, slat counting, as far as slat inspection, blister packing systems, and tablet sorters. So we have solutions for each one of these categories. Of course, Jekson's not just about tablet inspection. We also do serialization and track and trace. But this is a big sandbox that we play in when it comes to these types of 4 pieces of equipment. So how can Jekson help with these applications? The first one, I've talked a little bit about it. It's the tablet inspection system, TIS. This is a system that's designed to integrate to the OEM's electronic counter. All right, so when we're talking about, we're talking about companies like Kramer or CVC or CountTech or Swift Farm and more, other companies that that do not have a type of vision system on their electronic counter. Now, one thing that's pretty unique here is this is not just the vision system. This is a system that actually inspects, ejects on the fly the actual non-conforming product, right? So that's extremely important because if you have a broken tablet, right, you have a broken tablet, could be just a simple broken from other mechanisms like maybe a pre-feeder or an elevator or something in the coding system, some transfer system of tablets. There could be a lot of reasons why you could be breaking tablets. The other thing is you could be breaking tablets that are coded. You got broken tablets. I've seen broken tablets come to different types of filling applications that actually went through the whole coding process. So it could have happened at the compression side, right? So there's a lot of different ways a tablet can be broken. There's also, because of the different handlings of solid dose, you might have spots on tablets or a discoloration because of coding processes. The really unique thing about our vision system is we detect spots, broken. We inspect rogues. If something's not supposed to be there, we can stop. But what's really neat about keeping up with line efficiencies and quality of product is rejecting on the fly. We look at every single tablet that's being processed and we track it, we reject it, and we confirm that it was rejected. And that's what our TIS system does. If you look here, we have our camera system up at the top. This is actually integrated on a Kramer 600 series machine. But like I said before, it could be integrated with other types of electronic counters. So with our system, we're rejecting the reject product before it even gets to the counting eyes of the electronic counter. Our system, think of it as like a big sensor, and you sit it on top of the system, and we integrate directly into the OEM's piece of equipment where it looks like an OEM piece of equipment, but it's actually a Jekson piece of equipment. And as we're rejecting, the counter doesn't even know we're rejecting. So the counter is doing exactly what it's supposed to be doing, which is count product. That's its main purpose. That's what it was designed to do. It was not designed to do is inspect broken tablets. All right. Also, electronic counters cannot see color. Most of the time, they're basically just through beam sensors, like I talked about earlier. So they have no way to detect color. With our system, you can detect different shades of color, the contrast of color. We also can stop the system right away for possibly like a screw or a paper clip or some type of flashing from a bottle. That was from a previous process or a piece of plastic, because a lot of times bulk is brought in. If it's not in a big Gaylord, it's brought into a bucket or other types of totes, and they dump it, and it usually has a liner in it, a plastic bag. Or maybe you have a Ziploc where somebody cut it and it fell into the process, a small piece of it. We can see that. And when it's a rogue product for something that's non-conforming, we will stop the system and shut it down. And since we're CFR 21 Part 11, it takes dual signatures. And for a rogue tablet, that system will stop, lock it down, and a supervisor will have to come up and enter their password in order for us to move forward. Now, I've touched base a little bit about this, but the different types of defects that our TIS system can see is broken tablets, spots on products, hairline fractures or cracks. We can also see color variations. I've touched base a little bit about that on different coating situations that we've seen because of the discoloration, or maybe you have a wrong capsule, like a #1 capsule that could be one color, but a #1 capsule could be a different color coming in our system. We would see that, shut it down, and stop it. If it's a half capsule, we would basically accept it and reject it out the front. Foreign objects are a big deal. That can actually cause a tremendous amount of customer complaints from customers that might see a foreign material in it, or even broken tablets. There's a lot of complaints customers give every day to pharmaceutical companies about just simple things. And one of the big things is broken tablets. I want to talk about, here's a simple video of a TIS system on a Kramer 1620 running in production. So I thought you guys might be interested in seeing this. This is a system that has 6 cameras on it. There's 2 dual head 1620 Kramer CVC 1220s, 1620s, and each inspection system has 3 cameras. And what we're doing is, as the product is coming out on the counting trays, we are actually looking each and every single product. Sorry about that, guys. Operator error here. As the product is coming out on the counting trays, on the actual feeding trays, we actually inspect and we look at the product. And you can see here, there's actually a broken tablet that we've rejected out the front. So that means that broken tablet did not go in that bottle. This is a system we really pride ourselves on designing systems that will easily integrate with the OEM. In this case, this was CVC. So we try to make our design look like the OEM's piece of equipment, so it doesn't look like a Band-Aid. It looks like it's part of the OEM equipment. You can see there's not a lot of airlines. There's industrial quick disconnects that we have on our system. So this is a system running about 120 bottles a minute. The next product I want to talk about is the tablet sorter. This is our TIS sorter system. This piggybacks on the TIS technology, but in this case, Jekson has developed our own feeding mechanism that allows our TIS to inspect and reject and confirm our rejection out the front. So this is a system that runs about 2,500 to 3,500 tablets per minute. That's with a single module. That's with this right here. This platform is about 42 inches wide, so it's designed to take 2 modules at one time. So you could be looking at 5,000 to 7,000 tablets per minute. And it is expandable. So if you wanted to have 4 of these modules on there or 3, this is easily expandable out to the right or to the left. It's a mobile system. It has a dedusting option on it that we can dedust the product. If you have a really dusty product, we have a very unique way of basically cleansing the product, cleaning it, and getting the dust off and evacuating the dust that's basically being adhered to the side of the tablet. What's really neat about this machine is it can be used inline or it can be used offline. Now, what does that really mean, right? So offline means you can have it in a separate room by itself, and you're just loading product. And what it's doing, it's bringing the product out. It's on 3 different trays, and the last tray, we're basically looking for brokens, we're looking for spots, we're looking for discolorations, we're looking for conforming product, and everything that's good basically drops down below. Again, it can go into a bucket, it can go into a gaylord, it can go into an elevator, whatever you want it to go into, it can go into that type of apparatus. But it could be in a separate room. You could be running it anytime during the day, first, second, third shifts, and you can be setting this thing up to run for production. And what's really, really neat about this, if you've got products coming in from an outside source, either, like I said, domestically or internationally, sometimes you don't know what type of quality might be coming in. Or if you had a batch that you brought to the packaging line and it's running, you got all these broken tablets in, you don't have 100 resources to go through and look at all these broken tablets off to the side. Something like this might really benefit you because you can take that product back, right? Take it off the packaging line. Or if you discover this anomaly before you get to the packaging line, you can actually go ahead and, because of the production demand that you're required to get packaged for your particular customers, you could take the system, run the product through it, eliminate all those anomalies, eliminate the fact that you got broken tablets in your bulk, eliminate the fact that you got discolorations in your bulk, just get rid of any coated broken tablets, any rogue tablets that might be in there. So it's basically being used offline to sort, right, before you bring it to a packaging line. The second way you can do this is an inline system. So you could take the same machine, it's on casters, and you can roll it up behind, let's say, a electronic counter, right? And you bring the product up. Maybe you would sort it, elevate it up, and put it into that electronic counter hopper. It would be really nice also for blistering applications where you have blister packers that have dedicated tube feeders. And dedicated tube feedings, they require basically a really tight tolerance in the tube so the product can go down without shingling. And if they're really prone to jamming if you have broken tablets, right? Because they'll jam in the tube, stop up. They have the stop, pull out the orientation tray, the drop shoot trays, clean the jams in the tubes and start back up. So the whole line is shut down because of a little broken tablet. Or I'm inspecting before it goes into the blister, right? That means I'm getting rid of all the broken stuff before the vision system on the blister machine so I don't reject something else like a blister card downstream, which then you got to push the tablets out or you got to throw the whole thing away. So again, it pays for itself. It can be used in 2 different directions. It can be used offline or it could be used inline. Jekson's TIS slat inspection system. This is a very unique new product that we've come up with. We found that there was a great need in the industry for a different way of looking, a different way of integrating a slat inspection system and 2 different types of slat fillers. As everyone might know or might not know, a slat filler has been around since probably the early 70s, late 80s. Um, it's a workhorse. It's been a workhorse in the industry for a number of years, but it's basically a mechanical mechanism. It's a dumb piece of equipment because it's really chains and slats rotating around, filling a bottle, but the bottle fill count is based on the fill efficiency being 100%. If every cavity is not filled, then you're not going to get 100% in the bottle. And if you're not detecting that, that means a consumer will get a short count. Some people who use slat fillers actually put an extra tablet, they'll rotate an extra slat to put extra product into a bottle just to appease and satisfy the consumer that might have a chance of getting an undercount so they don't get customer complaints. That's more prominent in the nutraceutical world. On OTC or class 2 narcotics, obviously that's not happening. That's a more of a serious issue. If you're giving more than you're supposed to a patient or a customer, that's not a good thing either. So slats are really workhorses. They run really high speeds. There's different sizes of slat fillers. So I'm not going to do a dissertation on slats filling technology, but I want to talk about what we do to help the consumer get the right count, right? We're the only system in the world that builds an IP67 design slat inspection system, the only one in the world, which basically means you could take our slat inspection system, you could take it outside or into your clean room with a power washer and power wash the whole head, and it stays dry inside. We're the only company in the world that uses vortex cooling technology. We don't use any fans or filters because in a solid dose application, you've got a lot of dusty products that you run. Dust becomes airborne. It goes around, it gets sucked into your filters get jammed up. Then you start overheating your electronics, or the inside of your cabinets become very contaminated over time because you might be running 4 or 5 or 6 or hundreds of different products. That dust residue is just basically building up layer and layer and layer. And then when your technicians come into your control cabinets, they're having to be exposed to certain elements that might not be very safe. So again, we're the only company in the world that does the IP67 design. We use vortex cooling. We monitor the temperature of all of our cameras. We turn it on to cool and to turn off when we don't need the cooling. We're also the only company in the world that doesn't do the flashing light. The flashing light, which basically on a slat inspection, you're walking up to it and it's just blinding you with all the flashing that's going on. And that can cause some other health issues for people that might have some effect with flashing lights in front of them, right? We have what's called a non-flashing focus light. So we don't light up like the whole football field, right? When it comes to a slat inspection system or a slat filler, we don't light up the whole area. What we do is we light up only the 50-yard line. We only light up one slat, and that's the slat that we're inspecting. So you don't have this bright light basically illuminating all over the packaging area or in the operator's face. It's basically one light focused on one slat. Now we build systems that can accommodate a 20-inch or 40-inch slat inspection. There's certain ones that might be a little shorter in between those 20 and 40. We can adapt to that if that's required. Our speeds are up to 7 slats per second. That's what we can see, which is very, very fast for a slat filler. Normally slats are running around 3 to 5 slats per second, normally in a production, depending on what type of product they're running. We can integrate with PLCs that might be a newer type of slat inspection, a slat filler. We can integrate with the PLC that might take control of the tracking of the bottle for rejection, or we can take full control of the bottle handling and the rejection. It depends on how old a slat filler is and basically what does the customer want us to do. But the key to it is you will not need an operator in front of that vision system once it's put on a slat filler because it's looking for empty cavities, right? If you have an empty cavity, what do you want to do? You want to reject that bottle because you want 100% accuracy and count. You would have to have an operator in front of that machine to say, oh, there's an empty cavity. Let me put an extra tablet in there, right? With our slat inspection system, you don't need that operator because we see it, we detect it, we track it, we reject it, and we verify it. Let's say if you have a broken tablet. A broken tablet is going to sit lower into the cavity. We're going to see that. We're going to basically track it, reject it, and verify it and confirm that it's rejected. The other thing that's really interesting, what if you have a small screw or some type of foreign material that falls into a slack cavity? You know, how do you see that? So our system sees that as a foreign tablet, and we track it and we reject it into the bottle. Now we can do different types of slats. We can do actually different types of slats. It could be like blank slats, or it could be a continuous running slat system, or it could be um, a partial slat to get the accurate count. Um, there's just a lot of things we can do with our software to integrate with different types of slat configurations, right? So again, it can be a continuous running. It could be a stop and start based on blank slats between the active slats, um, or if the system is designed to have a continuous running of different types of slats, let's say like 4 good and maybe 4 that are partial blanks. And then they stop at each cycle. We can basically integrate with that application all the time. If you don't have a reject system, we can supply Jekson can supply our own reject system. If you have bottles coming in as a slug of bottles, we normally integrate a simple pacing wheel that paces the bottles out, just maybe like 0.1% slower than the actual speed of what the bottles are coming out in the slug. We create a gap, we track, and we reject, and we verify the rejection. The other thing I just missed on is our system does not tilt back. Our system, a lot of some of the competitors out there will want to rotate the whole slat back. It requires double acting air cylinders with valving and air hoses. Ours is a fixed point but it's still, so our depth of field is high enough where you can take the slats off and on without having to tilt the whole head back, which creates other issues. So we integrate with companies like Merle's, the old Laxos, um, integrate with modular, IPS, or King slat fillers. The last system I want to talk about is our BIS Smart. Our BIS Smart is a blister inspection system that has AI built into it. So if you have different blister applications, a blister packer could be cold form, it could be thermal formed. This system fits right after your feeding section and right before your lidding material, right? So you have the lidding material and your bottom material. Bottom material is basically a cavity. You have different types of feeding mechanisms that might feed that cavity. It could be flood feeding, track feeding, or it could be tube feeding. But in any case, you're going to need an inspection system on that. And why do you need that, right? So it's the same idea as what you have on the slat or you have on the electronic counter. It's all about and seeing non-conforming products, right? So we're looking for, is there a missing cavity in that blister card? Is there a spot on the blister, on the actual tablet itself, right? Is it broken? Is there something rogue that's not supposed to be there, right? Have you got 2 dispensing in one product in a cavity, which can happen with certain types of feeding applications, right? So with our BIS Smart with AI, it gives you the ability as a customer to set something up very quickly, right? So we have what's called a 1-button setup teach wizard, and it calculates the size and the shape of your product. It also calculates the tolerance, but at the same time, when it's calculating the tolerance of that particular product, you also have the ability to manually tune that tolerance to what might be required to critique it a little bit, fine tune it a little bit. It also detects the different types of product color, right? It also, you can set it up when you're originally setting it up, it'll detect what type of blister material you have. So there's different types of blister material out there. There's Aclar, there's PVDC, there's PVC, And they come in different colors, right? Acrylic can come in white. You got PVC could be clear or translucent. So there's different types of blister material that's out there that our system basically self-tunes to. Um, we can also look at different types of colors. It could be single, it could be multiples. We can look at like multi-cavity, like a bingo card, which has different product families in one blister card, right? You see that a lot today. What's also really neat is we have a built-in oscope, an oscilloscope that helps the technician if you want to debug something. It has an oscope built into the software, which is very unique. The other thing, it's just not limited to one type of blister machine, right? We can integrate with CAM. CAM is a company. We've done a tremendous amount of integration along with Ullman and Klockner, um, and also PharmaWorks, Micro and PharmaWorks, and also with LMAC blister machines. So this is a slide that kind of slid it up the top, but I want to talk about beyond pharma. So Jekson's not just about, vision. It plays a big part of it, but we segued our material handling with vision because both of them complement each other, right? Vision likes repeatability, right? In order to get repeatability to do a proper inspection or a proper printing, you got to have material handling, right? So we have a lot of different expertise in the material handling side of it. And that's kind of taken us, Jekson, in a different direction in some cases, different paths, because people are coming to us realizing our technology and our innovation and what we can bring to help solve problems for different customers every day. We've got different industries coming to us today and wanting to say, look, you guys can sort tablets. Can you sort projectiles? Right. And we took on a project that we can actually inspect different types of projectile and segregate the different types. Like if you want a 9mm hollow point versus a full metal jacket round nose type or a flat nose, we can designate between the two, or if you and reject what they don't want and keep what they do. Where they might have a person that's sorting 2 tons of projectiles every day and looking at the different types of projectiles. What would take them 2 or 3 days would only take us hours to do. We also do projectile counting. So we have some counters that allows that same type of industry to put a box underneath or a bottle and push a button, and it actually puts a projectile in that box. And to give you an idea of the speeds we can do, we fill like a 250 count box with a 9mm projectile in just over 15 seconds. So that's pretty fast. Um, the other thing that we do is we do projectile brass 360-degree inspection, where we'll take your brass, we'll sort it for you. We have a very unique design where we sort the product out and we orient it in a way where transfer wheels can pick it up. And then we look 360 degrees for fractures. We look for dents. We look for rim diameters. We look for primer presence. So these are the different types of things we do in that space, that type of space and industry. So we're utilizing the pharmaceutical knowledge that we have every day that we play in that sandbox, and we're kind of branching off because people are coming to us and recognizing our innovation and our technology, and we're helping them solve ongoing issues. The other thing we do here is inverted blister inspection. This takes our BIS technology and basically takes it and inverts it. So rather than looking from the top, looking for something that's not there, underneath, we also look. Now, why do you need that, right? So I mentioned earlier about a bingo card where we had a customer that had like maybe a 2 or 3 up index with 3 bingo cards, which are really big cards that have different shaped pockets in it that has maybe a tablet of this sort and a capsule of that and a caplet of that, and they're all different colors, right? And as the multiple feeders are feeding those products, and it's doing a great job, and the inspection says, hey, everything is where it needs to be. But just before the lidding material comes down on top of it, one, because of the index and because of the bottom material, it might do what's called a diving board, or it just flips out, and it flips out and goes into another cavity, and then the top material comes in, and then of course you've got the sealing side of it, and then the punch side of it. So before the actual die punch side of it, the customer came to us and says, look, can you guys, we're doing 400% inspection. We're taking every blister card out of this UPS 1070 MT, and we're looking at every single card, blister card, and making sure that we don't have a mix-up. One product jumped to another cavity. So what we did with the customer, we took out a station out of the Ullman, which was their embossing station. And we built a Jekson system, a Jekson station that slid right in where the OEM station was, looked just like an OEM piece of equipment that came from Ullman. And we actually did bottom inspection. And not only did we inspect, but we also tracked all the way down to the reject. So that eliminated a 400% inspection, which was 4 people at the end of a blister line looking at every single blister card and making sure that it was correct. And again, you can't validate a person, but you can validate a machine, right? Some of the other technologies that we're getting into is blister card handling. When it comes to crushed blister cavities and dents in a cavity. So we're going through an overhead belt, right? A vacuum belt coming out of a thermoformer, out of their transfer station from their die punch to a conveyor. Products are coming to a single file, and we pick them up, and we have what's called a 3D imaging scan, and we scan the bottom of the blister card, and we're looking for the volumetric size of each blister cavity. And based on that scan, we can see dents, we can see crushed blisters, right? And then the secondary inspection can be, we can double check to make sure from underneath that the right product is in the right cavity, and then all the products are in the cavity that need to be there. So that's a pretty powerful tool. And that's only a system that's about 4 feet long, and it has different types of inspection, those 2 types of inspection with reject on the fly and confirmation. And then it simply hands it off to the customer's conveyor, and then they can go on with downstream processes, which could be a vertical stacking magazine that basically counts it into your cartoner, or whatever you want to do for secondary processing down line. The other thing that Jekson really prides itself on as an innovative company is we don't mind customizing material handling if it's based around vision. But even if it's based around printing, we'll build custom system for you for material handling, because we believe in solutions, we believe in innovation, and that's just the Jekson way. That's just what we do. So we love helping customers, we love solving problems, and hopefully in the future, we can help you. Also, I want to mention to you that Jekson Vision Jekson Vision USA is based in Youngsville, North Carolina. We're just about 35 minutes from Raleigh-Durham International Airport. We're in a small village called Youngsville, North Carolina, which is by Wake Forest. And we'd love to invite you down to see some of our technology. So now we're ready for questions and answers.
Hi, Jim. We've got a couple of questions offline. I'm just putting them on the chat over here so somebody can ask them. Just give me a...
Sure. Okay, so one of the questions that has just come across here, and thanks for asking that question, is what's the maximum output or maximum speed of our TIS? So our TIS has the capability of inspecting 600 tablets per minute per track. So let's just say you have a Kramer 600 series that has 6 tracks, right? So 6 times 600 is 3,600 a minute. So obviously, if you have 2 modules, 7,200 tablets a minute, or if you have 24 tracks, A 24 track will give you around over 14,000 tablets a minute. So we can inspect faster than the electronic counter can produce products for counting. Okay, the other question was, what is the setup time for a slat inspection? So a slat inspection setup time is about 20 minutes. If that answers your question, it's pretty simple. It's basically putting the good product. If you have like different color products, you would put like maybe a white down and the other one would be a pink up or a purple up, whatever your capsule dual colors are. Or if it's just a solid white capsule or tablet or whatever, you just put it into those cavities. And underneath our vision system, we inspect, we teach, we take a grab image, we look at it and we say, all these are good. And then basically anything that's outside those parameters are considered bad. Now, obviously, as you're starting to run good product through it, maybe you want to tweak it because you might have a false reject because a parameter might be too tight. So we give you the ability to adjust that setting depending on what that reject was for. So the question came in is what kind of support is available for recipe creation? So this is a really, really good question because we have a different approach when it comes to service. Our approach is this: we're 24/7. And what does that mean? That means basically we in North America are supporting you from our Youngsville office, which is north of Raleigh, North Carolina. But obviously we have to sleep also. And our CCD group in India is also kicking in the same time that we're going off. Now, how do we do that? We do it through not just emails, but we do it through WhatsApp. Our WhatsApp allows us key personnel within our organization, including our India team, to be on point 24/7, 7 days a week. And how does that work? So if we have a customer that has a recipe that needs to be set up, they can ping us and say, hey, Jim, we need, or hey, CJ, or hey, AJ, or whoever, we need a recipe set up. We forget how to set this parameter, and no problem with us. So what we do is we go through TeamViewer, and it allows us to go directly with you within your system and helps you in an intuitive way to set up your recipe. Or if you're trying to figure out why this thing is rejecting something, right? You're getting maybe false rejects for some reason, and you need to fine tune something, or you forgot what that parameter really meant. So it's either picking up a phone, talking to us, right? Or you can text us on WhatsApp, which is a very, very powerful tool. And or the other thing is to TeamViewer. So you give us a text, we see it, we respond within 5 to 10 minutes, and we get online with your system and get you back up and running as fast as we can. So the other question is what kind of support is available for recipe creation? We talked about that. And what are you able to make real-time adjustments while the inspection is ongoing? And can the reject images be saved? Yes, and yes. So as you're running, as you're seeing the images on the screen and you're seeing certain parameters come up, which is giving you an output of a number represented based on that type of inspection you're performing, you can make fine adjustments to a point where it's rejecting or not. So that can be done on the fly, which is a very powerful tool. And at the same time, especially in our slat inspection system and our other TIS technology, we save the images, right? We save the last 20 images. So if we save the last rejected 20 images. So if you, for instance, let's say you had a rogue product come in and you had to stop the machine. We capture that image so the QA can basically come in, take that image out of our system and put it in their report. Or if they're saying, hey, I've got the last couple of hours, I've had this many rejects because of broken tablets, you can capture those images based on those broken tablets that you're seeing and create a report and show it to your QA team, which can also have meetings with your coding team and say, look, this is the things we're seeing on the line. Or you can even take it to your customer who's supplying you the product to package. And so you really have evidence of what you're seeing so they can create a better process to create better product. Power requirements. Most of our systems, 90% of our systems are on 110, 60 hertz. Usually you need a 15 to 20 amp breaker for that type of system. It's on our line, but it draws very little current. But it's nothing three-phase. We do also do 208 single phase, 60 hertz, but the majority of our systems are on 110. Any other questions?
Jim, I think we've had these questions. I'm not seeing any more coming up now.
Okay. All right. Well, again, thank you guys and ladies for joining our webinar today. It's been a pleasure hosting you. I hope it was very informative. I hope I didn't talk too fast. Sorry about the slide mix-up. But anyway, I think we got it all covered. And if you have any questions in the future, just please reach out to us at Jekson Vision. Again, my name is Jim White, and it's been a pleasure hosting you guys and ladies today. Have a great afternoon. Bye.